So now today we will discuss 8255. Now 8255 is an widely used programmable parallel IO device. Now the meaning of the parallel IO device is that suppose this is the two block and wire is connected between them is 2, like that. So data is transferred simultaneously from one container to the another container. So that is the meaning of the parallel IO device. Now in the case of the parallel IO device, data transfer will be much faster. So that is the meaning of the parallel IO device. Now what is the use of 8255 and why it is actually being introduced? Now 8255 is used to connect the IO device with the microprocessor. Now you cannot connect the IO device directly with the microprocessor. So suppose this is your microprocessor, this is your 8255 and this is your IO device. So IO device is connected with the like that 8255 connected with the microprocessor, and it can be programmed like that. You can see in the very simplest way that how 8255 is being introduced. Okay, it is a peripheral device used to connect the peripheral with this chip. Now 8255 has 24 bit IO pins, 24 IO pins. So 24 IO pins means it grouped into 888. That means 3 8-bit port is can be connected. 3 8-bit IO device can be connected with the 8255. So you can say that this is your port A, this is your port B, and this is your port C, obviously. So these three port is available in 8255, and within these three ports, 8-bit IO device can be connected with this 3 port. Now the flexibility is given to only port C. That means port C can be divided into 4-bit ports. That means 4-bit IO device, if the IO device size is smaller, that means 4-bit IO device is you want to connect with the 8255, then you can connect 4-bit with PC lower. This is maybe called the PC lower 4-bit and PC upper divided into 2 group. You can connect with that. That is the only flexibility. Otherwise you have to connect as a whole 8-bit for port A and port B. And next is your block diagram or the pin diagram. Now in the case of the block diagram, you can see that this is your port A. So port A is connected, any IO device port A is connected with that, with the port A, 8-bit IO device. This is port C. It has the given the flexibility 4-bit or as a whole 8-bit, whatever you want. And port B is again also 8-bit. So any external 8-bit IO device can be connected with that. And next is your D0 to D7. Now the D0 to D7 is called the control word. Okay, and this is very important. We will discuss this later, what is control word and how it is used, what is the meaning of that. And next is CS bar. You can see that this is CS bar, this is A1 and this is A0. These three are used in conjunction. That means as a whole. As a whole means these three as a whole decide which port is to be selected. That means if it is 00, port A is selected. If it is 01, port B is selected. If it is 10, port C is selected. And if it is 11, control register is selected. Now this chip select line is that for the use in just like every other digital electronics device. That means if this chip select line is high, then only this chip is selected. Otherwise this chip is not in any use. That means it is active low. So for the 0 input given to that, this chip is selected. So this chip is selected. So that's why this chip select line is used to select the chip, and rest is VCC, ground, read bar, write bar, reset, same as any microprocessor, same 8085. So next D7 to D0, that is your bidirectional data bus. It is used for control word. Next is your reset input. Next is your chip select line. Next is your read bar, write bar. And with the chip select, this A0, A1 is used to select the port A, port B or port C. And this is for port A, this is port B, and this is port C. And next is your VCC 5 volt plus 5 volt, and this is your ground 0 volt. Next, control watt. Now in the case of the control watt, only D7. Now the control watt and the relation with the 8255 is that 8255 will first talk to the control watt, then will decide which operation is to be selected just by seeing the bit pattern of this. That is the meaning of the control watt. Okay. Now in the case of the control watt, here we only discuss the bit D7. Now bit D7, if it is 0, used for BSR mode, and if it is 1, used for IO mode. BSR mode is full form is bit set and deset mode. It is used for port C, only for port C. We will see it later. It is a very simple mode of operation. And in the case of the IO mode, which is important for 8255, the IO mode is divided into 3 mode: 0, mode 1 and mode 2. Mode 0 is used for, if it is 1, that it is IO mode, and IO mode is again divided into 3 mode. That will be decided by the rest of the bit pattern. We will see it later. But first, IO mode is divided into 3 mode: mode 0, mode 1 and mode 2. Mode 0 is simple IO mode, very simple for the read and write operation. Mode 1 and for the handshaking mode of operation, where port C is used for handshake signal, and mode 2 is used for bidirectional data transfer. Okay. So that will be also written here. That means port C upper, port A, port B is used for as a whole 8-bit port, and 4-bit port C upper and C lower, port C. Okay, that is flexibility is given. And also 3 mode of operation is also written here. That means mode 0, mode 0, mode 1 and mode 2. Mode 0 is simple IO mode, mode 1 is handshaking mode, and mode 2 is used for bidirectional data transfer mode. Okay. So again, one more thing for discussing the control watt is which port is to be selected. I have said earlier in the whenever I discuss the block diagram, that these 3 is used as conjunction. That means if it is 0, that means chip is selected, then only these 2 are only is used. So after the chip is selected, if it is A1 and A0 is 0 0, then port A is selected. If it is 0 1, port B is selected, and if it is 1 0, port C is selected, and if it is 1 1, control register is selected. And rest for don't care condition, 8255 is not selected because this is 1. If this is 1, then 8255 is not any use. So now next we will discuss the what are the addresses of the different ports, because until and unless you don't know the addresses of different ports, you can't send any data. Suppose this is your port A, this is your port B, this is your port C, and you want to send some data to port A, you want to send some data to port B, you want to send some data to port C, or you want to read out some data from that port. You cannot do that until and unless you know the addresses of this port. Now addresses of this port can be accessed with the help of this pattern. Now as I have said that CS bar A1 and A0 is responsible for selecting the different ports of 8225. So you can say that whenever A1 and A1, this is 00, 01, 10, 11. So for that purpose A, B, C and control register is selected. Now as this is IO mode, okay, for the case of the IO mode, we know that the 8-bit address recognition is suffice. That means any IO mode is recognized by 8-bit address rather than microprocessor memory. It is identified by 16-bit address. So that's why we don't need A0 to A15 address. We only need A0 to A7 address for identification of any 8-bit port identification. Okay, so that's why here we use only A0 to A7 address. Now A0 to A1, that is responsible for selecting the different ports. Now rest of these are to be connected obviously with the 8255, so that all together can select the chip select. Okay, that means this combination, you can set different combination of this A2 to A7 to select the chip with the different configuration. Okay, here we have set A1 equal to 1 for that configuration, A1 equal to 1 for that purpose only, and all these are 0, all these are 0 means this is also 1, all the bit is 1. So here chip select line is 0, at the chip select line is active low, this line is 1. So you can see for that configuration the address is 1000 and 0000 like that. So this is 8 and this is 0, 80, 81, 82 and 83. So these are the control port address of the 8255. Okay, here we only concern with A, B and C. So that I have to remember 80, 81, 82 and 83. So port address of this A, B, C and control register. Next is your control register. Now the control register are very important in the sense that with the help of this control register you can 8255 is actually identifying what kind of operation is to be performed. I have said it earlier also. So here you can see that bit D7 is responsible for BSR mode or IO mode. Here it is written BSR mode and the IO mode. So if it is 0 then it is BSR mode, and if it is 1 that is IO mode. Okay, so as it is concerned with the IO mode, it is always set to 1 for that purpose only. If it is BSR mode, that is set to 0. Next, IO mode, I have said that there is 3 different mode in the case of IO mode, that is mode 0, mode 1 and mode 2. Which mode is to be selected from these 3 mode? We will decide from the D6 and D5 and D2 bit pattern. Okay, so if D6 and D5 is 00, then mode 0 is selected, and if it is 01 then mode 1 is selected, and if it is 1 don't care, then mode 2 will be selected. So these are the different combinations for the these 2 bit and for the selecting of which mode is going to operate. Next, bit D2 done the same thing, that if it is 0 mode 0 is selected, if it is 1 mode 1 is selected. So corresponding bit pattern has to be loaded into the control word for selecting the mode 0. Here we are concerned with the mode 0. So mode 0 means simple IO mode, mode 1 is handshaking mode, and mode 2 is bidirectional mode of operation. So here we are only concerned with the mode 0, that is simple IO mode. Okay, so next we are left with A, B and C, these 3 ports. Now in these 3 ports, these 3 ports can be operated as input port or can be operated as an output port. Now if any port can be operated as input port, then corresponding bit is set to 1. If it is output port, then corresponding bit is set to 0. That is the general convention. Now D4 is set to port A, D3 is PC upper, you can say that. So as it is decide the port A operation, now if this bit is 1, then the port A will operate as input port, and if it is 0, port A will operate an output port, and rest is true for all other ports. That means if port C, suppose this is port C, so if it is 1, then the port C upper will operate an input port and 0 output port. Rest is true for PC upper and port B also. Okay, now we will understand very clearly for the next example. In the next example we will load the control word pattern. Now for loading the control word pattern, first understand that this problem, in this problem there is some sort of switch is connected between ports and some sort of LED is connected between ports. Now switch is you can consider as an input device, and LED you can consider as an output device. So the switch is connected to which port? That is to be operated as an input port, and LED is connected to that port will be operated as an output port. That is your problem. Okay, so you can see that port B and port C lower, so you can see that port B and port C lower switches are connected. Okay, DIP switch, digital input switch. So you can easily say that these 2 ports must be operated as an input port. For that purpose, corresponding bit pattern should be set to 1, and port C upper and port A are connected as an output port. So corresponding bit pattern for that port must be 0. So that is the problem statement. We have connected some sort of switches, we have connected some sort of LED. Now depending on the switch, the LED will be on and off. Okay, so we are reading the input switch and we are outputting that switch to our corresponding ports, output port. So the problem statement is clear, I hope. So next we will discuss the control word format. Now in the case of the control word format, you can say this is for the reserve for IO operation. So IO mode, this bit is must be 1. For port A in mode 0, this is mode 0 operation. From the beginning I am telling that it is a mode 0 example. For that purpose these two bit must be 0. For 00 it is mode 0. Next bit D2 is also operation for mode 0 of operation, or mode 1 or mode 2, so it is 0 for mode 0 operation. Next D4 and D3 is reserved for port A and port C upper. Now port A and port C upper must be operated as an output port. LED are connected between these two ports, so it must be 0. And now the opposite example, port B and port C lower as unconnected, switches are connected, so these are input port, must operate as an input port, so these are 1 easily. So it is set to 1 because these are operated as an input port, these are set to 0 because this is operated as an output port. So all the bit pattern is loaded, and final bit our 83 hex. So our control word is 83 hex. Now whenever this 8255 reads this 83 hex, it will correspondingly know how to do things in, that means it actually knows what you want to do with the 8255. 8255 reads it and operates according to the control word.